Hello, everyone. On the last or the sixth webinar out of the series of Fusion webinars we've been delivering for the past couple of months, uh, I today's topic is advanced manufacturing tools and adaptive manufacturing in Fusion. I'm Anna Sotirovska, your host, and I'll be here to make sure that everything goes smoothly and all of your questions are answered. This is today's agenda. So we will be introducing ourselves a little bit for those that are first time joining us. We will go over the webinar highlights, introduce our featured expert, talk about the Fusion software, and then we will be sharing the recordings for the all past webinars. As I mentioned, my name is Anna Sotirovska. I'm the Partner Engagement Executive at KnowledgePoint. KnowledgePoint is the exclusive distributor for the Autodesk Learning Partner for the EMEA region. KnowledgePoint is working in the learning industry, is present with more than 25 years of expertise, and we are here to make sure to provide great educational resources for all of the learning partners. Today's topic or today's webinar, we will be exploring the advanced manufacturing tools. We will demo design for manufacturing, production, drawing. You all saw the drone on the last slide. So our expert trainer will be using a drone as an example. So without any further ado, I will leave the floor to Cengiz Kurtoglu, mechanical design engineer, and he will be conducting this webinar. If you have any questions at all times, you can feel free to put it in your Q&A box, and the question will be answered by Cengiz.
Thanks a lot, Anna, and welcome you all. Today, in the series, the webinar series will be the last webinar, unfortunately, but don't worry, it will be available on the YouTube channel, Knowledge Point. You can access directly all webinars. Today, we'll start with additive manufacturing and advanced manufacturing. Like traditional subtractive manufacturing tools available in Fusion. And also I will mention the methods of different types of manufacturing technologies. And as always, I'll start to speak about myself. I'm your trainer for this webinar. I'm a mechanical engineer. Mechanical design engineer. About 5-6 years I'm a Autodesk authorized trainer also, and I focused on different types of projects in the creation of medical devices and also different types of robotic projects. And if you are interested, you can check it out, Design Wagon channel. It's available in YouTube and Instagram. I'm creating different types of videos, training about the 3D design and mostly Fusion. Well, in this today agenda, we'll start with Autodesk Fusion, what's in it. We will be a quick intro, and we will pass the extension of manufacture workspace in Fusion. There are different types of manufacturing tools available in Fusion, like subtractive, additive, two different type, and also we'll mention about creating a G-code in Fusion directly using a mechanical part. And also, you have access a learning panel. You can open it up a new CAM tutorial 3D data, and you can learn by yourself directly in Fusion. You have access to all the data. I will show you all the folders. And for finish all of our video series, webinar series, we will be cover up all 6 webinars in the different type of methods like computer-aided design CAD, computer-aided manufacturing CAM, and computer-aided engineering like simulation solutions in Fusion. Well, let's start with quick intro for Autodesk Fusion. As always, I'll start about what is Autodesk. Well, it's a 3D design, engineering, and manufacturing capabilities available in this platform. And also, you have access directly in the cloud system. You don't need to install at all, and you have access directly on your web browser. The interesting thing in Fusion, well, there are different types of workspaces. Like today, we'll discuss about the manufacturer workspace, sorry. But there are lots of other, for example, product design extension, generative design extension with simulation, signal integrity about electric parts and thermal simulations, manage, etc. We will be discussed in our presentation. Well, on a design workspace, we already discussed about the solid modeling, like this table-wise components. For modeling, we will discuss in this session because we haven't time to discuss about the form modeling parts, but we will create a T-spline model, and I'll try to explain in details of T-spline modeling. And also you have access to mesh, sheet metal, and surface modeling. Well, in Fusion, after you create your parts in 3D, you have access to assembling. As you can see here, there's a robotic arm with the well assembled, and you have access to move all joints that you want to go as directly for the main parts. Well, on the other hand, there is a workspace called render. On render workspace, the most interesting thing for me, you can send all parameters after you create it. You can send all demands on render image to create high quality render image. You can use the render farm has access directly using Fusion, because to create a render on your local server, it could be hard. For it depends on your parameters of your local PC, but you have access directly to the Autodesk server and the cloud base, and you can gain lots of times using render workspace. And also there is another workspace called animation. Well, in animation workspace, you have access to manipulate the cameras, or you can access the tool of auto explode different components. You can move with one click. But for this part, particularly robotic arm gripper, I created motion study in the design workspace. Between the workspaces, you have access to manipulate, you have access to modify same components with the same parameters, but the workspace will be changed and you have access lots of different things. Well, on the other example of the workspace simulation, well, static stress simulation, model frequencies, electronic cooling, thermal stress, nonlinear static stress, structural buckling, a dynamic event simulation, which is great to if you have if you need to solve complicated projects. You have access directly to nonlinear static stress and also dynamic event simulation. In the simulation workspace, you have access shape optimization, topology optimization to lightweight your parts. And also you have access injection molding simulation. And the updates will come every 45 days and it will be grow, I think, about the simulation workspace. Well, there's a displacement recording for robotic gripper arm holder to explain us after the load on the parts and the constraints on the back of the robotic arm gripper. And also these parts are generatively designed. If you want to check it out in deeply in our last 2 webinars about the simulation and generative design, you can check it out on the YouTube channel. Well, today we will discuss about the manufacturing, computer-aided manufacturing, or it's called CAM. For example, in this animation, in this simulation, we can say simulate for this part, because there's a machine, 3-axis milling or 5-axis milling. You have access to 3 or 5-axis in Fusion. After you create your parts in design workspace, you can pass to manufacture workspace, and you have access to create tool paths. As you can see, there is a tool. It's available on the library of Fusion. After you customize your tool, there's lots of parameters you can enter for this creation of CAM module, 3-axis milling. And as you can see, there's a line. It demonstrates as a blue line. All the blue lines, it explains us the tool, the machine will be passed for this blue line, and it affects on the part directly. As you can see, there's a stock, it's green, and after it passes for all the surface, it will be subtract for these parts. And this type of manufacturing molds, manufacturing methods, it calls subtractive. The approach for subtract the all materials, traditional methods of manufacturing. On the other hand, as you can see in the right side of the screen, there's another manufacturing methods which is called additive manufacturing. Well, it's not subtractive, it's additive. It's the logic of the 3D printing or additive manufacturing. It's add the, for example, thermoplastic material it adds layer by layer. It creates layer by layer. As you can see, first layer, third, 70, 500. As you can see, it grows layer by layer. You don't need to subtract at all. It creates just the part, but it needs to support for some angle. As you can see, it creates blue parts. Normally in the final final project, we don't need to use this part, but it's using these parts to support these overhang angle issues. We will discuss in the next slides. Well, also Fusion have a drawing technical drawing workspace, which is quite important for manufacturing issues, manufacturing projects, because in the communication between the engineers, designers, technicians, all the people who interested about the projects to create the parts, the technical design, it's quite important. Technical drawing, it's quite important because we can add all necessary information just the paper, just the technical drawing paper. It's important because in the manufacturing sites, especially in the subtractive, there are lots of information to explain the manufacturers, the details of the parts. And also it's important for additive manufacturing for finishing the finishing issue about the parts. Well, if you are an electronic designer or a mechatronic designer, it's really handy tool for Fusion. You have access to create 2D and 3D PCB documents. As you can see, there's an air quality sensor. Normally, this is a 2D documentations for PCB. You can edit, you can modify all the parts, all the necessary components, and after that, you can switch the 3D workspace on the electronic design, and as you can see, the all parts created in the 3D workspace, which is great for mechanical designers or designers because they need to all dimensions for the electronic parts, and 2 and 3 teams could be work together actually. And I'd like to mention about a very brandly new competition which is organized by Knowledge Point and Autodesk, and there's a winners for Design It in 2023. Well, different types of students like industrial design, engineering come together to gain the digital skills, and the Design It will there's a as a project for they were asked to model, to create 3D projects using Fusion, a product for growing crops with renewable energy. Well, after you think about the projects, normally it's very complicated to create a project. Well, they have a one day to finish these projects after they learned and they obtained knowledge about the Fusion. They created these projects in just one day, about the product, about the renewable energy. Well, as you can see, quite interesting to create these parts. From the first place, the Team Yin Yang, and second place for Team Titan, as you can see. And also, as we mentioned in our old webinars, in the Fusion, there's not just a create a 3D design. As you can see, there are render workspace and the animation workspace. You can create different types of animations also. In the third place, also Team Concept Squad. As you can see, we will try to open this video also. Well, if you're interested about this kind of information, this kind of projects or the competition, you can check it out, the Knowledge Point website to get knowledge about the all brand new information. Well, we'll continue to generative design workspace. Well, this is my favorite workspace because normally the AI powered algorithms create these one part, and not just one part. You can assign lots of parameters as a materials, as a load, as a manufacturing method. Well, the algorithms create lots of solutions, lots of design solution for your demand. Well, as you can see, Fusion have a different capabilities to create the projects as soon as possible, because to prototype, to create a project, it's very easy to start on Fusion. Well, today I'll try to explain the manufacturing methods on Fusion, available manufacturing methods. Well, as we mentioned, computer-aided design and computer-aided manufacturing CAD/CAM utilize computers to design drawings of part, feature boundaries in order to develop cutting toolpath and CNC machine code, part program. Well, by using CAM, the G code, machine code, is specified cutting tool. Cutting tool data are already defined. As you can see, there's a tool here, and in the Fusion, there's a library to use to select your custom or well-manufactured tools in the companies that support these tools. Well, drawing in CAD is simply constructing a drawing using lines, arcs, circles, points. Its position are parts. As you can see, the parts, there's a slot on this side, and the manufacturing tool, it tries to cut, subtract in this region. Well, CAD and CAM is now a conventional method to create mechanical drawings and computer numerical control. It's called CNC programs for machine tools. Well, engineers can create drawings needed or to share them electronically within the manufacturing department. And in general, they are using different types of export tool like STL, like STEP, IGS, DXF. There continue to be huge different types for these type of file. On the other hand, Fusion have access to all steps, and after you create your 3D parts, you can create your G code also to send it your machine. Well, it's a great positive side for the software. And also remember, the overall objective of CAD/CAM is to generate a toolpath for CNC machine, and the method of subtractive in the form of CNC program. Well, it's imperative to have full understanding of a rectangular and polar coordinate system. Well, in our sites, we will be create a sample on the Fusion. Well, there is a type of explanation in the understanding of cutting tool, like selection, cutting tool selection, speeds, and feeds. We will be discussed on the projects on Fusion. And also, it's quite important to work which type of material are using, but because some materials are very durable, very hard to subtract on the using some cutting tool, it's very important to use which kind of material are you using. Well, on the other hand, there's a additive manufacturing, also known as 3D printing. It's a revolutionary set of manufacturing technologies. To understand the method, there is a different characteristic fabrication for this type of technique. Well, the process of additive manufacturing builds up raw material to create objects layer by layer here, as you can see, and building by layers is the opposite of subtractive manufacturing, as we mentioned before, which cuts a design out from a block of material. Because the process is additive and computer-based directly, it's also capable to complex design using 3D printable digital models. Well, all shapes and designs can be considered possible, including complicated concepts that may have previously been thought too difficult or too costly to make. But with the additive manufacturing, no, it's not. Another characteristic of additive manufacturing is that it can use a wide variety of raw materials. While it's often thought as being just for plastic, but it can actually a number of different materials like metal, like plastic to ceramic. There's a range of materials that could be used in additive manufacturing also. And companies are also applying additive manufacturing using sand, glass, wax, or even materials with the features of human cells in the bio 3D printing. As the technology develops, additional materials are being introduced at the record pace. Well, as you can see, as I mentioned before, on the capabilities of the cutting side or milling side, and also there's a library to access different types of 3D printers. It's great because if you have for example, a Formless, Form 2, or Creality, or EUS on your site or on your home, you can create the G code directly in Fusion, and there is different parameters you can modify while you're creating your parts on the machine, on the 3D printer, because all companies are creating software to explain their machines to and algorithms to use their machines. But Fusion have access all different 3D printers at the same time. And now, for example, you can select Formlabs from tool, and then you can create your G code, you can modify it, and then you can good to go. Well, as you can see in the right side of the window, there is a capabilities on Fusion. Additive, as we mentioned, cutting, milling, turning, the traditional methods of machining, and also you have inspection and machine connector as a capabilities. On the left side of the machine library, you have access to all different companies. And for this particular manufacturing method as additive, there's a technologies FFF, DED, binder jetting, SLA, etc. We will mention now, for example, titanium powder is now being used for 3D printing of parts in the jet engines, as well as skull implements or hip replacement. Well, change in equipment and materials are accelerating the acceptance of additive manufacturing as an industrial production tool. These three essential characteristics, being additive, capable of complex design, and using a wide variety of raw materials, enable 3D printing to support innovation in ways that are impossible with the traditional manufacturing method. Well, from one of designs for specialized or customized needs to hybrid application that create molds or dies for traditional manufacturing, additive manufacturing pushes past previous manufacturing limits with a toolless process that reduce costs and lead times. Well, in the 3D printing presents ever increasing opportunities for companies to innovate and become more competitive. And also designers can quickly create prototypes to test with the internal trust structures, recreate old or out of stock parts as for custom cars. Also reverse engineering artifacts from long lost culturals, and even help doctors operations for prepare for difficult surgeries. Well, there is a manufacturing revolution taking place, and it's only just beginning, and Fusion have access all of them, and it updates month by month. You can check it out. Well, we'll start by looking at three techniques in Fusion, and in general in additive manufacturing use plastics and polymers. Polymer materials like photopolymerization uses a liquid photopolymer resin for 3D printing process. A build platform is lowered into the resin, and it creates layer by layer your parts using UV light moves down, either curing or solidifying your resin layer by layer. These techniques delivers incredible accuracy and finish. It's also fast and suitable for creating objects of various size. It's primarily used for wearable items, soft robotics, bendable electronics, etc. Well, as a second technique that I like to mention, materials jetting works like a inkjet printer, and nozzle jets the material onto the built platform, which hardens. This process is repeated by layer, and these machines vary in complexity and accuracy, but benefits include a very low waste of materials and the ability to create multiple parts and colors in the single printing, in the single part. In the window, as you can see, for the volume supports, you can modify different parameters for your 3D printing G-code creation. As you can see, there is a support over angle. Well, it's also in the Fusion. If you click and or just wait a few seconds, there's an informative pop-out. Support overhang angle, as you can see, determines the angle at which supports get generated for down-facing surfaces. Well, the angle is measured from the horizontal plane, enter a value between 0 degrees to and 90 degrees between them. Well, as we mentioned before about support, it's not a subtractive, but also it creates more parts to support your some faces. It's not obligatory, but in the some conception, in some design, machines, 3D printing machines need to create parts. Well, here is the 15 degrees overhang angle. It doesn't need to create support for here in the 15 degrees. But after that, it's past the 15 degrees and it should create the support path. But if I enter 55 degrees, as you can see, there are lots of more supports between them here. You should be aware about the supports issues, and in the Fusion you have access to see before to go to your 3D printing machine. You have access to simulate this one, and you can see before to go. Well, in the process simulation, as I mentioned, Fusion have manufacturing type, additive manufacturing, and also in the manufacturing, you have access to simulate while the machine are creating the part, which parts will be hot as a temperature. Well, as you can see here, in the process simulation, displacement issues for the parts, because yeah, the technology is new and it creates very complicated parts, but there are some issues about machining the machine. For example, if you think about the FDM, fused deposition molding, thermoplastic are melting in the nozzle, and then it's cooled and it creates layer by layer on the XYZ axis. But if the dimensions are changed or the temperature are dramatically changed, there could be a displacement. As you can see here, there will be a displacement, and Fusion have access to process it before to go to the machine. Well, it's quite interesting and important game changer for the whole project because we already discussed about the simulation, like static stress simulation, but this one is different. This one is about directly the manufacture issues. Well, after after I see the manufacturing issues, maybe before go to the manufacturing process, I could be redesign my parts and resimulate my new revision part. Well, that could be some key benefit for your whole projects, long-lived projects, the life of the projects. Well, there is also different types of manufacturings. As you can see, there's a tool where it could be mentioned on Fusion directly to use the Fusion. And also you have access to finish your surface 4 or 5 axis cam, and also you have access to library, and there's a surface inspection tool to analyze finish your faces, the quality of your face of your parts. As you can see, there's a 5-axis tooling. You can change the your parts to obtain different type of tool. As you can see, a rotary axis tool as a project, and also for Fusion in the manufacturing side, you have access to modify the G code on Fusion. Well, normally there's a lot of software and they're creating the G code after you can modify it, but there's always issue between the exporting parts or re-exporting. Well, the interesting thing about the software, you have access the design with the same extension. You have access to manufacturing to create your G code. Well, on our next slide, well, we will see milling and turning manufacturing types on Fusion, and also additive manufacturing type on Fusion. There's different types of manufacturing method, but it's available on Fusion. And also there's a 2D cutting manufacturing type also. It's quite important for industry in the all areas. You have access to use directly in the Fusion also. Well, the learning panel, it's very instructive, it's very educational for your training program, because in the milling, for example, we will see the projects on Fusion. There are different type of tools which creates different types of different types of um, how can I say? Well, for example, the face 2D adaptive pocket, it creates different zone to subtract the these area. We couldn't use the face as operation. Yes, operation. I was searching the this word operation. There are lots of different operation. As you can see here, we are changing tools to operate to subtract these areas. Well, on the other hand, for example, we change the type of manufacturing. It was milling and also turning. It could be a turning manufacturing methods for this one. And also, for example, 2D cutting on Fusion, it's also available 2D cut operation. If you need, you can use the 2D cut operation, and after you can export the NC code for your laser cutting machine, for example, and you can good to go to create some projects on your particular projects using different materials. Well, it's a 3D printed parts, and also it was generatively designed, like we mentioned about the drone chassis. Well, generative design, it takes into account your manufacturing method, and if you select 3D printing, additive manufacturing, it creates very complicated parts to manufacture it with the traditional methods. But with the additive manufacturing methods, there's no limits. In general, we could say in general, but we have capability to create complicated geometries, or generative design have capability to create complicated parts, and with the additive manufacturing you have access to create them. Well, let's pass to Autodesk Fusion to work with the projects directly on computer-aided manufacturing. Before to pass on my local Fusion, you have access any kind of computer. You just type fusion.online.autodesk.com in your web browser, and you have access directly. You don't need to install the software. You have direct access to the Fusion for all parts, for all projects, and all workspaces. Well, let's pass to Fusion. As you can see, there is a different workspace called manufacture. Before past manufacture, normally as a default, we already create different parts like robotic arm, like table wise, or different types of mechanic parts. But in this particular workspace manufacture, the tools are changed, as you can see. Well, now I'll try to create a part. It could be mechanical part. For this project, as you can see, there is a stock on that. Well, the stock means it could be aluminum, or it could be let's say stainless steel. Well, after we assign the materials, we have to create a setup on manufacturing workspace. Well, we already created a setup for this one. As you can see, there's an operation phase, which is quite important to start with the phase, because we don't know the stock will flat on the z-axis. For example, the tool will come on top of the parts. As you can see, there's a blue line, and the part will become for, as you can see, it simulates the face tool. It comes directly on red point, and it goes in the green line. It doesn't touch the surface of the stock, but after the blue line, it starts here, it starts to subtract the materials. It's not it's 0.1, 0.2 millimeters, but it's not important. The important thing is we could be flatten the part of the top of the surface. After we flat the on the top of the parts, 2D contour. There is another operation. Well, I think the material, it's not so heavy. We could check, but the contour will start directly to cut the parts. Well, it could be a plastic, but the tools should be much durable, much harder than the materials, or much sharper on the edge. It's lots of details on the tooling part, but if you know your machine, you already know the details of your parts, of your custom tool. You just need to enter your parameters on Fusion. Well, 2D contour will pass, as you can see here. It starts to cut on the edge of the parts here, and it's finished. It's gone. And after that, 2D pocket. Well, 2D pocket, it creates, as you can see, the region, like slot region, like bigger cylindrical surface in the parts directly, and bore to create the thread for your parts. Bore, it's like a milling on the region that necessary for the parts, and drill also, it creates region for screws, and tapping to finish it up. Well, let's simulate. After I push this Control and Shift button, and at the same time I'll select all of them, and I press the right click on my mouse, any of them, generate or simulate. I'll try to simulate, but if you never generate, you need to firstly generate, and then you have access to see the how it works on the simulate. Well, we passed the simulation workspace, and it's quite new actually. And the old tools are gone. In the manufacturing workspace, when I select the simulate, the old parameters tools are gone. It just the simulation workspace, like simulation workspace. We're working in manufacturing workspace, but it's very simplified the complexity of the software actually. Well, I simply play the animation or simulate. As you can see, the first phase operation, it passed. It's not so heavy operation, just flatten the parts, and we know it's all surface, it's flat. And then 2D contour will directly pass, and it creates the all region in the end of the parts. Well, after 2D contour, 2D pocket, the tool 2D for the operation of 2D pocket, it came and it start directly to pass here. As you can see, it's like hard enter for this part, but it works. But if you know to manipulate your parts, you just modify it, you just customize it, and you can good to go. But it's if you don't know your tools, you always, I'll suggest you always start with the smaller size pass one side, and after that you can pass the bigger diameter for your parts. There is a question, I can check it out quickly. It's not a problem, you can ask anytime. How can we know that we need to use this axis to milling the model? Well, as I understand from the question, well, there's a different types of axis. For example, for this project, we are using 3 axis for these parts. There's a 1, 2, and 3 axis for this particular project. But also there's a 5 axis milling. I will show you for in the data panel. You have a different type of part projects. You can check it out to understand the details of the 5 axis milling, as we did in the 3 axis milling, for example. Well, we'll continue for 2D packet here. As you can see, well, it's done, and it continue to at the same area to the packet. If you need, you can change all the parameters for your G code on Fusion directly. After 2D packet operation, it'll pass to board. If you need, you have speed it up here. Well, after board, it passed. While the material is plastic vinyl for stock, as we mentioned, because if there's a aluminum or titanium or stainless steel, that could be quite difficult to enter the tool directly, something like that. But the plastic, in general, it's not a big issue. Well, I'll finish it up, the simulation. As you can see, it's all done. Now, let's pass another project, which is 2D adaptive CAM modeling. Well, for the different types of manufacturing method, normally, if you have a machining, you can check your machining name, machine name on Fusion. Well, how can we do that? Well, there is a manage here machine library. In the machine library, you have access different types of manufacturing methods, as we mentioned, additive manufacturing, subtractive, milling, turning, and you have a filter to see them at the same time. Well, for example, I have a Formlabs Form 2 as a 3D printer. I just need to create a G code for this 3D printer, and I just need to search this printer. Well, firstly, in the capabilities, I pass the additive, and for example, it's a SLA technology for this example. As you can see, Anycubic, there is a Prusa and BAM, Formlabs Form 2. Well, it's available in Fusion, and also you have information about the dimensions of your plate and capability. As you can see, it's explained SLA 3D printing on the desktop. Well, it's great. And also, we can change the filters as milling. For example, there is a different types of industrial CNC machining. You have access to use as a machine to create your G code here. For example, Mazak VCN 570. Milling capability, dimensions here, a little image and lots of information for your particular machine here. And also, and the filters, cutting, for example, and turning. You have access to these parts, but not in the library directly, but you have access to create your G code on the tab. Well, let's quickly check it out, these parts. After creation of stock, well, I'll make same thing. We'll pass the simulate site on the simulation. Here, there's an adaptive. To the adaptive, it start. And here to the packet, it depends on your operation. Some operations are details. It depends on your tools. It depends on your diameters for your tools. Let's check it out, the different types of tools. For example, for the 2D adaptive, right click and edit. Well, if I pass the edit of the tool, Fusion needs to verify your needs. For example, which size of your tool, it asks directly which type of tool you are using. Well, if I select the tool, it opens a new page like machine library. It's a select tool. In the select tool window, like the machine library, you have access different type of tools. For example, for the 2D adaptive milling, I need to use 1/4 inch diameter flat end bit here, as you can see. Well, it's also used for other parts. Well, if you want to more information about this tool, there's a 2D workspace. Also, you can check it out, your tool in 3D workspace directly. And here there's a description, diameter 0.25 inch, shaft diameter 0.25 inch, overall length 1.75 inch. Well, there's a lots of information about cutting feed rate. Well, also the coolant, what type of coolant, surface speed, spindle speed as an RPM. Well, these are already available in the Fusion library. There's a lots of, and also in inch and metric, you have access the tools on the Fusion. Well, there is a flat end mill, face mill, tapered mill. As you can see, you have access lots of different types also in the all. Well, here, as we mentioned, there's a laser cutter, plasma cutter, and water jet for the cut operation also. In the tool category, I passed the milling. Here, for these parts, they already used for face mill and, for example, 8mm diameter face mill. And also, if you need it to customize your tool, As we mentioned before in the materials, you can customize your materials, copy and paste, add your parameters, and also you can customize your tool directly. Create, copy and paste, and enter your values on for your custom tool. You can enter your information, and after that you can create your G code directly on Fusion. Well, for these parts, for example, we finished, it's all done, it's all great. I just need to create a G code for my parts. Well, in the actions here, there's a G code generator to understand your machine, these type of equipment, the tool. Well, here in the post process, well, creates a specific NC code for the program to understand your every movement for your tool. Well, after that, you can generate it, post process it, and you can good to go. Well, we mentioned about the traditional subtractive manufacturing type, and also in the Fusion you have access additive manufacturing G-code generator. Well, let's say FDM type, fused deposition molding, using thermoplastic to create these parts. Well, if you don't have a you don't need to a 3D printer directly. There is an Autodesk generic FFF machine. You don't need to any 3D printer, but if you have a 3D printer, you can find your 3D printer as the same category in the manage library. We pass same window. Just filter your additive method as a manufacturing method, and then as we find the formlabs form 2, we have access to find the formlabs form 2. Here, for example, additive and machines, Fusion library, FFF. For example, here there are lots of 3D printers. And also it's interesting to get information about your 3D printers or new 3D printers if you are interested. Well, here it's the same logic like we did. There's a generate and simulate additive toolpath. It's already generated using PLA material. Well, here in the play mode, same logic, it starts to create layer by layer to use to create G code for this project. Well, if you like to simulate your parts, you have to generate. For the additive toolpath, you also need to take into account support. Support is quite important for 3D printing technologies. Well, I'll let you to get more information about the overhang test, because you have access these same projects that we mentioned on your Fusion account. Well, in the data panel, normally we mention on our last webinars, you have CAM samples. If you enter CAM samples, there is a additive manufacturing tutorial, tutorials. If you need it, just pass. And as I did here, you just click the all operations at the same time and then start start simulation. That could be for your projects before pass to machining side, because we can modify our parts directly here to make. Well, I'd like to cover up all of webinars about Fusion. Well, normally we start with the CAD, computer-aided design tools, which is available on Fusion. For example, we can pass the projects of T-spline modeling, because on our webinars we focused on generally mechanical parts, but on Fusion you have also access to modeling, NURBS modeling based T-spline modeling. Well, it's quite different between the computer-aided design in the solid modeling and T-spline modeling. But at the end of the project, all T-spline models could be converted to solid model. As solid model, you can add a part that you created in the T-spline models. You can pass to 3D workspace as a solid model. Well, and also after creation of your T-spline models, you can reopen it to modify them as you need. Well, fortunately, there's a timeline here. As you can see, there's a create model on the T-spline model. You have access to create organic shapes on Fusion. Well, here, as you can see, the parts of glass glasses, I think, it creates by using T-spline for modeling. Well, I will go to the inside of the T-spline models here. There's a different approach to create your parts. Basically, you don't need to add your dimension in the beginning. You can edit, you can modify anytime you want. It's more flexible to create your parts. Well, also in the operation of opening the finished form, I like to mention about the render workspace, because we are on materials you can use for appearances. Here it's arrived. Well, as you can see in the details of the T-spline models, like NURBS modeling, you need to create vertex lines, and you can modify it anytime you want as a modification for these parts. For example, normally on the CAD modeling, solid modeling, we have to create a sketch using extrude or revolve tool, but here you can modify it to manipulate directly to, for example, face or line or vertex, which is quite flexible, and you have access different types of modification here, and there is a manipulator to manipulate your parts to change the position as a degree, as a rotation here, as you can see, or to move the parts like 10 millimeters, 9 millimeters here, as you can see, it tried to change. Well, it doesn't look good, but I just want to explain the T-spline modeling details. It's open to use to find the details. Well, and also, as you can see, there's a symmetry between of them, and you can use the symmetry tool for to create symmetrical T-spline models on the T-spline form workspace. Well, for the last part, I just want to show you chess projects that I created for a particular projects. For on these projects, normally we are using the materials as customized materials, but we also have access to use these materials as appearances on the render workspace. It's interesting because in general, for your clients, for your jury, for your professor, you need to explain on the presentation, or just explaining for your 3D models. It's important to use the colors on your projects, and for on the other side, photorealistic way, you can use the render workspace to create a eye-catching image on Fusion directly. Well, here, as you can see, it assigned different types of materials, like wood for each parts of the chest plate, or the plastic black or plastic white color for the parts. Well, after you see, normally it's available on render workspace, and at the same time you have access to the design workspace. I just want to explain the capability of Fusion have switch to workspaces. It's quite smooth between the render to design. After design, for example, manufacture part. Well, there is a turning projects for this chest part. If you want to learn more about the manufacturing, you can pass to data panel on your own Fusion, and you find the CAM samples, and then for the turning projects, you have access to get knowledge, details of these manufacturing parts. Well, after finish my presentation, I will pass. If you participate on lately, we just mentioned about the Autodesk Fusion works in the web browser. You just type fusion.online.autodesk.com, and it's available on all projects, all workspaces on your web browser directly. Well, in general, for all 6 webinars, I try to explain Fusion capabilities to focus on different types of workspaces, like design workspace, like CAM modeling, simulation, animation, render, and etc. Well, I'd like to thank you and congrats for all 6 webinars. I appreciate you to participate these webinars on live. Also, if you are watching these videos after these live sessions, I hope it will be educative, these videos for you. And if you have any questions, you can send a mail, or if you need any help about the 3D design projects, you can send a mail, or on YouTube or Instagram will be available. And for these videos, if you are watching on the other platform, it's available in Knowledge Point YouTube channel. All 6 webinars, you have access directly. Well, I'll stop share my screen for now.
Thank you for Cengiz. I'll take over the screen again, so we can finish this webinar. So I want to remind everyone for the Autodesk education. So if you go on the Autodesk education link, you can find or you can download the Autodesk Fusion 360 and also other softwares, and it is a good opportunity to test all of your technical knowledge and skills and put it into real work. These are the after this webinar, we will be sharing this recording same as last time. On this link, as Cengiz mentioned, you will find all of the webinars previously, if you haven't had a chance to watch it live as they were. I want to thank you everyone for your time. I want to thank Cengiz for his dedication and delivering this amazing series of Fusion webinars. I hope it helped you. We've all learned something new. And yes, if you have any questions, feel free to send us an email, and we will be answering your questions. Thank you for your time. And if there isn't any questions, we will be concluding this webinar here. Thank you, everyone.
Thanks a lot. Thanks a lot, Anna. And thanks a lot for your message and for your participation. And have a nice day.
You too.
Thanks.